SwiftUI lets us attach custom gestures to any view, then use the values created by those gestures to manipulate the rest of our views. To demonstrate this, we're going to attach a drag gesture to card view so it can be moved around. And we'll also use the values generated by that gesture to control the opacity and rotation of the view. It'll curve away and fade out as it's dragged. This takes surprisingly little code because SwiftUI does so much for us. I think you'll be really impressed. First, add this new @state property to card view to track how far the user's dragged. @state private var offset equals cgsize.0. Next, we're going to add 3 modifiers to card view placed directly below the frame modifier. Remember, the order in which you apply modifiers matters, and nowhere is this more true than when working with offsets and rotations. If we rotate then offset, then the offset is applied based on the rotated axis of our view. For example, if we move something 100 pixels to its left, then rotate 90 degrees, we'd end up with it being 100 pixels to the left and rotated 90 degrees. But if we rotated 90 degrees, then moved it 100 pixels to its left, we'd end up with something that was rotated 90 degrees and moved 100 pixels directly down, because its concept of left got rotated. Where things get doubly tricky is when you factor in how SwiftUI creates new views by wrapping modifiers. When it comes to moving and rotating, this means if we want a view to slide directly to true west, regardless of its rotation, while also rotating it, we have to put rotation first, then the offset. Now, offset.width will contain how far the user dragged our card, but we don't want to use that for our rotation because the card would spin too fast. So instead, add this modifier below frame, so use 1/5 of the drag amount. Rotation effect, .degrees, double offset.width divided by 5. Next, we're going to apply our movement so the card slides relative to the horizontal drag amount. Again, we're not going to use the original value of offset.width because it would require the user to drag a long way to get any meaningful results. So instead, we're going to multiply it by 5 so the card can be swiped away with small gestures. Add this modifier below the previous one. Offset x, offset.width times 5, y0. While we're here, I want to add one more modifier based on the drag gesture. We're going to make the card fade out as it's dragged further away. Now the calculation for this view takes a little thinking, and I wouldn't blame you if you want to spin this off into a method rather than putting it in line. Here's how it works. We're going to take 1/50th of the drag amount so the card doesn't fade out too quickly. We don't care whether they've moved to the left, negative numbers, or to the right, positive numbers, so we'll put our value through the abs function. If this is given a positive number, it returns the same number. But if it's given a negative number, it removes a negative sign and returns the same value as a positive number. We then use this result to subtract from 2. The use of 2 there is intentional because it allows the card to stay opaque while being dragged just a little. So if the user hasn't dragged at all, the opacity is 2, which is identical to the opacity being 1. If they drag it 50 points left or right, we divide that by 50 to get 1, and subtract that from 2 to get 1. So the opacity is still 1, the card is still fully opaque. But beyond 50 points, we start to fade out the card. Until at 100 points left or right, the opacity is 0. So add this modifier below the previous 2. Opacity, 2 minus, double, abs, offset.width divided by 50. So, we've created a property to store the drag amount, and added 3 modifiers that use the drag amount to change the way the view is rendered. What remains is the most important part. We need to actually attach a drag gesture to our card to update offset as the user drags the card around. Drag gestures have 2 useful modifiers of their own, letting us attach functions to be triggered when the gesture is changed, called every time they move their finger, and when the gesture is ended, called when they lift their finger. Both of these functions are handed the current gesture state to evaluate. In our case, we'll be reading the translation property to see where the user's dragged to, and we'll be using that to set our offset property. But you can also read the start location, predicted end location, and more. When it comes to the ended function, we'll be checking whether the user moved it more than 100 points in either direction, so we can prepare to remove the card. But if they haven't, we'll set offset back to 0. Add this gesture modifier below the previous 3. Gesture, DragGesture, on changed, gesture in. We'll set our offset to be gesture.translation. Then on ended, underscore in. If abs self offset width is greater than 100, I'll do a comment here saying remove the card. Else, our offset 0. Go ahead and run the app now. You should find the cards move, rotate, and fade away as they're dragged. And if you drag more than a certain distance, they stay away rather than jumping back to their original location. This works well, but to really finish this step, we have to fill in the remove the card content so the card actually gets removed in their parent view. Now we don't want card view to call up to content view and manipulate its data directly, because that causes spaghetti code. Instead, a better idea is to store a closure parameter inside card view that can be filled with whatever code we want later on. It means we have the flexibility to get a callback in content view without explicitly tying the two views together. So, add this new property to content view below its existing card property. Var removal is your closure with no parameters, returns void. It's optional with a default value of nil. Now we can replace remove the card with a call to that closure. Self.removal ? Then open and close parens. And that question mark in there means the closure will only be called if it's been set. Back in content view, we can now write a method to handle removing a card, then connect it to that closure. First, add this method that takes an index in our cards array and removes that item. Func remove cards @index int. Cards.remove @index. Finally, we can upbit the way we create card view, so we use trailing closure syntax to remove the card when it's dragged more than 100 points. This is just a matter of calling the remove card @ method we just wrote. But if we wrap that inside a with animation call, then the other cards will be automatically slide up. Here's how your code should look. So I'll say with animation, self.remove card @index. Go ahead and run the app now. I think the result looks really great, and you can now swipe your way through all the cards in the stack until you reach the end.